me, because otherwise I'm just going to stand here and wait. So we started off the class by solving equations. So let's go back and solve some equations. So I want to solve the following equation. So let's start off with 3 plus the square root of 3x plus 1. And that's equal to x. So this was from our very first day of class. It's a radical equation. I have 3 plus the square root of 3x plus 1, and that's equal to x. Okay, help me solve it. What do we need to do first? What's our first step?
Isolate the radical.
So let's move that 3 to the other side. So that's going to give us the square root of 3x plus 1 is equal to x minus 3. Good. Now what?
Square both sides.
Fantastic. Thank you. That'll give me 3x plus 1 on the left side. On the right side, I'm going to go ahead and write that as x minus 3 times x minus 3 to remind myself that I have to FOIL. So we end up with 3x plus 1 equal to. Okay, when we FOIL on the right side, what are we going to get?
X squared minus 6x plus 9.
Good. Fantastic. Okay, so far so good. Now what? We get rid of the radical. Is this a linear or?
Quadratic to 0.
Yeah, it's a quadratic, so we're going to set it equal to 0. So we'll move over the 3x and the 1. So minus 3x minus 1. And if you do that, we're going to get 0 is equal to x squared minus 9x plus 8. And then what's left should factor. Somebody help me factor that. So we're looking for factors of 8 that add to 9.
8 and 1.
8 and 1 are perfect. Good. And because we're adding them, they're both going to take the first sign, so they'll both be a minus. So anytime you add, they take the first sign. If you're subtracting, the bigger number takes the first sign, the second number gets the opposite. So solving each of those, we're going to see that x is equal to 8 and x is equal to 1. But because it's a radical, and we know that we can't take square roots of negatives and goofy things happen, we're going to check those. So let's take the 8 and plug it back in for the x. That'd be 3 times 8, which is 24, plus 1 is 25. Square root of 25 is 5. 3 plus 5 does equal 8. So the 8 works. Now we'll check the 1. 3 times 1 is 3, plus 1 is 4. Square root of 4 is 2. 3 plus 2 does not equal 1. So that one's extraneous. It doesn't work. So only the 8 is a solution. So don't forget to check. But again, when I go back in and look at quizzes and things, I'm looking for that as answers, and I'll catch that and give partial credit on it. So nice. So you'll have one of those on your review today. I'm impressed. Good job, folks. Okay, still solving. What if we have 2x to the negative 2? So the negative 2 exponent minus 3x to the negative 1 minus 4 is equal to 0. So 2x to the negative 2 minus 3x to the negative 1 minus 4 is equal to 0. So this was on day 2. We did things like this. Does anybody have a suggestion on what to do? Looks kind of ugly.
Create u for substitute.
Yep. So we're going to come in and let u equal the x to the negative 1. Always the middle variable and its exponent. So then by default, that first variable and exponent is going to be your u squared. So we have 2u squared minus 3u minus 4 is equal to 0. Okay. Any questions with that? Okay, now I picked this one. This is a lot uglier than what you're going to do, but I wanted to make sure that you could handle ugly stuff. 2 times 4 is 8. Factors of 8 that subtract to 3, there are none. So in other words, 1 and 8, 2 and 4, neither pair subtracts to 3. So that tells me I have to go to the quadratic formula in order to solve it. And we haven't done a lot of that. We just need more practice at it. So we're going to use the quadratic formula. Again, yours on your worksheet is factorable, but this one's not. So we're going to say u is equal to the opposite of b, that would be a positive 3, plus or minus the square root of b squared, that's that negative 3, I'm going to square it, minus 4 times a, which is 2, times c, which is a negative 4. It's going to be all over 2 times a, which is 2. So again, order of operations is the key here. We're going to clean up inside the radical first. So that negative 3 squared becomes a positive 9. The negative 4 times the 2 times the negative 4, that's going to give me a positive something. And 4 times 2 is 8. 8 times 4 is 32. And that is all over 4. So u is equal to 3 plus or minus the square root of 41 over 4. You want to simplify the radical if you can, but 41 is not prime. It's prime. It doesn't divide by anything, so we're kind of stuck at that point. So now what we're going to do is the unsubstitution. So to unsubstitute, remember u was x to the negative 1. So what we now have is x to the negative 1 is equal to this fraction. 3 plus or minus the square root of 41 over 4. Okay, now what? What do we do with this x to the negative 1? What does x to the negative 1 mean?
It's 1 over x.
Yep, so that x to the negative 1 becomes a 1 over x. And now we'll cross multiply. And if you remember when we did these before, we found out that what you're really doing is just reciprocating both sides. So you're going to get an answer that's the 4 all over the 3 plus or minus the square root of 41. And as far as I'm concerned, you can leave it there. You don't need to worry about rationalizing things. So that's our final answer. So again, the steps were, first of all, make your substitution, letting the middle variable, the x, to the negative 1 be your u. Solve for u, and then unsubstitute at the end of it. So yours is factorable. This one was not. And that's about as ugly as they can get in that first chapter, is that question. So any comments or questions about that? How are we feeling? Like we're staying on task? We know what we're doing? I hope.
Yes.
Yeah.
Yeah. Okay, we're still solving. Let's go do a couple of inequalities just to remind you of the inequality work we've already done. So again, the directions are going to say to solve. What if we have negative 3 is less than 2x plus 1 over 2, and that's less than or equal to 4. So negative 3 is less than the quantity 2x plus 1 over 2 is less than or equal to 4. Now, once we are finished solving, we're going to come in and graph the solution set and then write it as an interval. Okay, what do you want to do first?
Multiply everything by 2.
Beautiful. We're going to multiply everything by the common denominator, just get rid of that fraction. So we're going to multiply the left side by the 2. We're going to multiply the middle by 2. And we're going to multiply the right side by 2. So 2 times negative 3 gives us a negative 6. That's less than. Now in the middle, the 2 that we multiplied by cancels with the denominator, and you're just left with the 2x plus 1 is less than or equal to, and the 2 times the 4 is going to give us an 8. Wonderful. So you got rid of the fraction. It's always the first step. We don't like fractions. Okay, now what?
Subtract 1.
Yep, good job. I subtract the 1. And again, from all the sides, that means the middle, left, and right. So that's going to give me a negative 7 is less than 2x is less than or equal to a positive 7. And then the final step. Let's go ahead and divide everything by the 2. So we'll get a negative 7/2 is less than x is less than or equal to a positive 7/2. There's some symmetry going on there, looks like. Okay, now that I have that, I need to interpret that and write it in an interval notation. So I'm going to graph it on a number line. So here's the negative 7/2. Here's the positive 7/2. Okay, on the negative 7/2, do I need an open circle or a closed circle?
Open.
Good. And on the positive 7/2?
Closed.
Yay! And because x is trapped between those two inequalities, the graph is trapped between the two inequalities. So it's just the region between those two values. Okay, so that's the number line graph, and now that's going to give me my interval notation. So then the answer that I'm going to want, we're going to go from 7/2 negative to positive 7/2. What do I need on the negative 7/2? A parenthesis or a bracket? Anybody? Negative 7/2, parenthesis or bracket?
Parentheses.
Good. Now the
Bracket.
positive 7/2.
Oh, parentheses.
So because of the open circle, we use a parenthesis. Because of the
Bracket.
closed circle, we use a bracket. Yep. There's your answer. Good. Then once we got through with the inequalities, the next day we did the absolute values. So this was one of those. So let's say we have the absolute value, and again, the directions still say solve. The absolute value of 3x minus 4 is greater than or equal to 6. Okay, so absolute values are not your typical kinds of solving. You have to remember that there are 2 inequality statements we need to write. So we had an equation 1, and then we had an equation 2 that we worked with. To write equation 1, what am I going to write? Or what is equation 1? The inequality.
3x minus 4 is greater than 6.
Yep, greater than or equal to 6. So all you do is just drop the bars. Okay, when I go to write the second one, what am I going to write?
Three x minus 4 is less than negative 6.
Exactly it. So 3x minus 4 is less than or equal to negative 6. So you flip the inequality, you change the sign on the right. Correct. And then we just need to solve both of those. So you go solve them on your paper. Take a few seconds and do that. Okay, so when I solve them, on the first equation, I got x is greater than or equal to 2/3. On the second one, I have an x is less than or equal to negative 2/3. Is that what you guys got?
Yeah.
Okay, now we're not done because we need to interpret that. So we're going to go to the number line. And again, when you go to the number line, make sure you get them in numerical order. So the negative 2/3 is going to go on the left side, and the positive 10/3 is going to go on the right side. I should be consistent on how I write my fractions. Okay, and both of them, do we need an open or a closed circle?
Closed.
Yep, nice. They're both closed. And then we have to tackle them one at a time. So the first one gave us that x was bigger than 10/3. So numbers that are bigger than 10/3 are to the right. The other statement gave us x is less than that negative 2/3, so that would be to the left. So in this case, they're pointing away from each other. So then how are we going to write our answer? So then in interval notation, the answer would be, so we'll have 2 pieces. The left piece is going to start at negative infinity and go towards negative 2/3 with a bracket. And that takes care of the left piece of the graph. Okay, then your right piece of your graph is going to start at 10/3 and go towards infinity. And that would be your answer. And that's pretty much what we worked on last week. So solving all kinds of equations. Okay, any questions on the solving?
No.
Nope.
Yay. Okay, so then let's move into some stuff that we did this week. So we talked about the application problems, and we'll work those guys in a minute. I wanted to move on to the distance and midpoint stuff. So we're going to be given 2 points. So we're going to let point 1 be 5, -2. And point 2 is going to be equal to -1, -6. Okay, so the first thing I want to do is find the distance between them. So let's find the distance. And hopefully you started making up your little card of formulas. So the distance formula was the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, so let's start plugging some numbers in. What am I going to use for x2?
-1.
And then minus x1, which is 5. Okay, so somebody else tell me what we're going to use for y2.
-6.
Good. Minus the -2. Fantastic. Okay. So cleaning up on the inside, -1 minus 5 is a -6. We're going to have to square that still. Over here we have -6 minus a -2. That's going to make that a +2. So -6 plus 2 is a -4, which we're going to square. So that's going to give me what? 36 plus 16, which equals 52. Okay, but you do need to simplify that. So I'm going to recognize that 52 is even. So I'm going to try and divide it by 4, and I'm betting it divides by 4. 4 times 13, maybe? They got their calculator handy?
I do. What's the?
52 divided by 4.
Yeah, 13.
Okay. So we're going to take the square root of the 4, which gives us a 2. The 13 stays on the inside. So the exact answer is 2 times the square root of 13. And then if they wanted a decimal, you could take the square root of 52. But again, I like the exact answers. So, okay, that's the distance formula. And again, we'll need that on Monday or Tuesday when we talk about circles. So it'll come back into play fairly quickly. We also did the midpoint formula the same day. So let's go find the midpoint between that pair of points. So the midpoint of the line segment is the correct wording. And if you remember the midpoint, it's the average of the coordinates. So you add the x's together, then you add the y's together to get the midpoint. It's the only place where we see a formula with pluses in it. So that would be 5 plus a -1 all over 2. And then it would be the -2 plus the -6 all over 2. And for some reason, this is where you just make sloppy arithmetic mistakes, so be careful. 5 and a -1 is 4 over 2. -2 and -6 is a -8 over 2. And then reduce the fraction. So 4 halves is 2, and -8 halves is a -4. So the point that's halfway between those two on the line segment is the point 2, -4. Again, we need that when we do circles. the only reason we do it, to help us with our circles. So is everybody okay with that one?
Yes.
Yay. Okay, now we're going to go do one that's a little bit more complicated, similar to something you're going to do on your review for Sunday, or for Saturday. Sorry, Saturday is when it's due. We want to find all the points on the x-axis that are 6 units from the point 4, -3. So we want to find all the points that are actually on the x-axis that are 6 units away from the point 4, -3. Okay, so the best way to start these guys is to draw yourself a picture of what it's trying to tell us. So what we're going to do is go plot the point. So we have 1, 2, 3, 4, 1, 2, 3, 4, -3 is right there. We know that we're on the x-axis, so I always go to the positive side just because it's easiest to draw. So there's some point over here. It's on the x-axis, and I know that this distance is 6. Okay, well, if I'm on the x-axis, do I know either of the coordinates for the point? Do I know the y-coordinate? If I'm on the x-axis? So in other
Define
words,
it
just
there,
the
isn't it?
yeah, it's just 0, that's exactly. And the x we don't know, so we're just gonna call it x. So that gives us everything. Now we're gonna just go straight to the distance formula. So I'll write it again. You probably don't need to, but I find that the more I write it, it helps you guys memorize it. So we know the distance is 6. That's going to be equal to the square root of. And to make it look nicer, we'll do x minus 4. If I went the other way, 4 minus x is a little bit harder to deal with at the end, so it's easier to go x minus 4 squared. Plus, and then we'll do 0 minus a minus 3 squared. Let's clean it up a little bit. So we'll have the 6 is equal to the x minus 4 squared plus the 0 minus a minus 3 is going to give me a positive 3, and a positive 3 squared is 9. Okay, so now we're down to solving. What's the quickest way to solve it from here? Does anybody remember what we did? Literally like the day before. Would have been what, Tuesday, I think it was. Anybody?
No, I'm always comfortable. I just like foiling it.
Okay. See, and I just think it takes more effort, but we can do it that way. There's nothing wrong with that. So let's go ahead and do it that way. So when I FOIL that out, I'll get an x squared minus 8x plus 16 plus the 9. So that's going to give me x squared minus 8x plus 25 is equal to 6. And again, this is why we solve quadratics, so that we can solve these equations when we're moving forward in the class. What do we do next?
Square both sides.
Yeah, I'm going to get rid of the radical first. So that'll give me 36. I'm watching to see how low on the board I am. Is equal to x squared minus 8x plus 25. And then we'd set it equal to 0, so we're going to move the 36 over. Trying to figure out where to go. I ran out of room. Guess I'm going to erase my picture and kind of work backwards. Never a good thing to do, but. Okay, if you move the 36 over by subtracting it, you're going to get 0 equals x squared minus 8x. 36 from 25 should be what, 9? Is that right? 25 minus
11, isn't it?
11, yeah. I don't like your way of solving it. I like my way of solving it. Looking for where I made a mistake, because that doesn't factor, and I know that we're not going to the quadratic formula here. Maybe we do. No, maybe it's an ugly answer. Maybe it's not as nice as I think it is. Okay, I guess we'll go to the quadratic formula, because I don't spot a mistake. So x is equal to 8 plus or minus the square root of 8 squared minus 4 times 1 times negative 11 all over 2 times 1. 8 plus or minus, that'd be 64. 4 times 1 times the negative 11 is going to be a positive 44 all over 2. That's 8 plus or minus what, 108 over 2. Okay, so I have to deal with 108. Again, it'll divide by 4. 25, 2, so 27. Oh, it'll divide by more than 4. I bet it divides by 12. So I just need to break it down to where I can deal with it, right? Well, no, let's use 4 and 27. So it's 4 times 27. So that's really 4 times 3 times 9. Okay. So the square root of the 4 is a 2. The square root of the 9 is a 3. Left over on the inside is a 3 all over 2. So that's 8 plus or minus 6 times the square root of 3 all over 2. And then I reduce the 2 top to bottom. So 4 divided by 8 divided by 2 is 4. 6 divided by 2 is 3 root 3. Well, that's really ugly. But to answer the question, Ben, we know the x-axis. So these are the x coordinates. So one of the points is 4 plus 3 square root of 3 comma 0. The other point would be 4 minus 3 root 3 comma 0. So not nice points, but they do exist. You're saying, don't do that to us on a test, right? Or a quiz. I actually want to backtrack and go my route with the solving just to show you how much quicker it is. So I'm going to go back to this spot. And what I'm going to do is square both sides right here. So that'll give me 36 is equal to x minus 4 squared plus 9. And the next thing to do is to subtract the 9. And when we subtract the 9, we're going to get what, 27 equals x minus 4 squared. And then I'm going to square root both sides. So that's going to give me plus or minus the square root of 27 is equal to x minus 4. You don't need the parentheses. Then all I need to do is add the 4 to the right side. So I get x equals 4 plus or minus 27, and then simplify the square root of 27, which is 3 root 3. So we get the same answer both ways. So it is just an ugly answer. But to me, that's a little bit quicker than actually falling it out and heading through the quadratic formula. But it's up to you. It doesn't matter. As long as you get to the same answer, either way, you're good to go. Okay. Comments or questions? You will see one similar on your worksheet. It has nicer answers than this, but it is very similar to it. Yeah. Okay, let's do one more before we tackle some application problems. This is from yesterday's lecture. And you probably haven't done this homework. Well, in fact, I know nobody's done this homework yet. I checked this morning. What I want to do is I want to find the intercepts and test for symmetry. So we're going to find the intercepts. And test for symmetry. And the equation we're going to use is x squared plus y squared equals 1. So x squared plus y squared equals 1. It's a good equation to lead us into Tuesday's lecture, it really is. Okay, let's go find those intercepts first. How do I find my x-intercept? Remember from yesterday?
Set y, or yeah, y equals 0.
Yep, so we're going to replace the y with 0. So that'll give me x squared plus 0 equals 1, or x squared equals 1. So x is equal to the square root of 1, which is 1. But anytime I'm solving and square rooting, I have to remember to add that plus or minus. So I end up with 2 of them. I have a 1, 0, and a negative 1, 0. Okay, what about the y-intercepts? How do I find my y-intercept?
Set x equal to 0.
Replace the x with 0. It's going to look very similar because then that would be 0 plus y squared equals 1. So y squared equals 1, you'll square root both sides. Y is equal to plus or minus 1 also. So we're going to cross the y-axis or touch the y-axis at 0, 1, and 0, negative. Good. So we found all of our intercepts. If we were graphing it, right now this is what we've got. We know we cross the x-axis here and here. We know we cross the y-axis here and here. What does that look like to you guys? I've got those 4 points. That's all I've got.
Circle.
Yeah, that's going to be a circle on Tuesday. So we're going to see that on Tuesday. So, okay, let's go figure out the symmetry. So we're going to test the symmetry to the x-axis first. So, and again, this is us looking at the symmetry. So if I'm testing the x-axis, what letter do I replace?
Y.
Yep, you always replace the opposite. So that would be x squared plus a negative y squared is equal to 1. But a negative y squared is still a positive y squared. So since this is the same as the original, and again, here's my original. This is the one we just came up with. It's the same. So yes, we have symmetry. So symmetry to the x-axis is a yes. Okay, what about the y-axis? So this time we're going to replace
Have negative x, or
Yep.
well, you'd replace x with a negative x.
Good job. So replace our x with a negative x, but because we're squaring it, we can see that it's not going to change anything because a negative number squared is positive. So again, it is the same as the original. So we now know that we have symmetry to the y-axis. Okay, we can kind of see that. We can see how we're folding across the x-axis here and folding across the y-axis here. So when we go test the origin, what do you think is going to happen? You think it's also going to have symmetry to the origin?
Yes.
Yeah, you are correct. So we'll replace both the x and the y, and we'll see that it's the same. Sorry, I'm getting really sloppy here. I'm also noticing that my first marker is running out. So what was that, 7 days of lecture and the marker's gone? It's like, wow.
Like breaking wine on the ship.
It is like, wow. It happens a lot faster at school because so many people use it, right? So we know we have symmetry to the origin. Beautiful. And again, if this were drawn in as a circle, we could see all 3 types of symmetry there. So, okay, so that gets you through the nuts and bolts of what we've been doing, everything but the applications. So what we're going to do for the applications, how are we doing on time? 33, we're doing okay. I'm going to help you set up the ones that are actually on your worksheet to do, but I'm not going to solve them. I'm just going to help you get them set up. So the first one we're going to take a look at is, this is number 12, directly off your worksheet. And it says, Steve is a recent retiree. He requires $5,000 per year in extra income. So he needs $5,000 a year. in extra income. That might be, I don't know, above his PERA and his 401 and all that kind of stuff. He's got $70,000 to invest. He can do part of it, invest in an A-rated bond paying 8% a year. And he can also invest in a certificate of deposit paying 5% a year. We want to know how much money should be invested in each to realize exactly the $5,000 in interest. Okay, so this one's a little different than the one we did in class on Monday because they only gave me 2 interest rates. They didn't give me a third interest rate. I'm still going to go to that same kind of chart that we were using. So I'm going to have the amount. I'm going to have the interest rate. And then the last column is going to be the amount times the rate. So we know we've got a 8% and we know we've got a 5%. We don't have another interest rate, so I'm just going to put a dash down there because I don't have a number to put there. Okay, so we basically have 2 investments. We have an investment 1, an investment 2, and then we have the total. Where are we going to put that $70,000?
Just the first amount.
In total?
Exactly. So we're going to put the 70,000 down here. Nice. Do we know how much we're investing at 8%? No, so that's our X. And then what are we going to put in the amount for number 2? I got 70,000 total.
70,000 minus X.
70,000. Okay, so we know to multiply across. So this is going to be 0.08x. This would be 0.05 times that 70,000 minus x. Okay, now I run into a slight bit of problem here. I don't have an interest rate to multiply by the 70,000, so I can't multiply across in that bottom row. But what do I know he needs total in terms of those investments is the 5,000. So I don't have to multiply in that last one. I already know that that answer is 5,000. Okay, and how do you write your equation from there? Or what would the equation be?
0.08x plus 0.05 parentheses 70,000 minus x equals 5,000.
Beautiful. That's it. You got it. Okay. And then you need to finish that. So that's number 12 off your worksheet that's due on Saturday. All you have to do is finish that one. Good to go. Comments or questions about setting that up? And that worksheet, the review to date that's due, I think is worth 20 points. So it carries more weight than a normal assignment because it's longer than a normal assignment. So, number 13 says Clarissa and Shauna working together can complete the exterior of the house in 6 days. So if they work together, it takes them 6 days. Clarissa by herself can do it in 5 days less than Shauna. So Clarissa, 5 days less than Shauna. I don't know how long it will take Clarissa to complete the job by herself. Okay, so this is a work-only problem, and if you remember, the formula for that was 1 over the first person's time plus 1 over the second person's time equals the 1 over the time together. So we need some variables floating on here. Let's come in, and since Shauna is the bigger amount in terms of days, and I know that because Clarissa can do it in 5 days less, I'm going to let Shauna be an X so that Clarissa's time to paint the exterior of the house is X minus 5 days less. So if it takes Shauna 10 days, then it takes Clarissa 5 days. If it takes Shauna 12 days, then it takes Clarissa 7 days. And I think we have everything we need now. We know how long it took them together. We know how long each of them take. We can write our equation. So we'll do 1 over the first person's time, which is x, plus 1 over x minus 5. That's the second person's time. And that's equal to 1 over 6, the time working together. And there's your equation. Any comments or questions about it up to that point? And can you handle it from that point? So do you know what to do next?
Would you get like a least common denominator? Is that what it's
Yeah.
called?
Yep, beautiful. And your LCD in this case is the 6, the x, and the x minus 5. So we're going to multiply everything by that. So we're going to multiply by a 6, an x, and an x minus 5. Now, I like to do these by inspection. Basically, when you multiply by the common denominator, you're going to have whatever is left, whatever was missing. So from the first fraction, it has the x. It's missing the 6 and the x minus 5. So when I do the canceling, that's what's going to be left. So the second fraction has the x minus 5. So what is left, or what is it missing? The 6 and the x. The third fraction on the other side has the 6 already in the denominator, so it's missing the x and the x minus 5. And that's as far as I'm going. So I'll let you finish it up from there. You are going to get a quadratic that does factor. So it's a nice factorable one when you're all done with it, but you do need to finish it. Okay, any comments or questions?
Is the least common denominator is 6x x minus 5, or just 6 parentheses x minus 5?
It's also the extra x. So it's 6 times an x minus 5.
Okay.
Because you've got this. This is different than this in terms of factors. So they're both part of that common denominator.
Gotcha.
We didn't do any like that. And the reason we didn't is they're back in those sections that we skipped over that you should have tackled in a previous course. So unfortunately, that's the way the courses are written. Okay, we've got one more to set up, and then we're going to call it good for today. So this is number 14 on your worksheet. You've got 3 application problems. It says a coffee house has 20 pounds of coffee that sells for $4 a pound. So $4 a pound, and we've got 20 pounds of it. How many pounds of a coffee that sells for $8 a pound? $8 a pound. Should I mix with that to make, with the $20, I'm sorry, let me read that again. How many pounds of coffee that sell for $8 a pound should be mixed with the 20 pounds of $4 a pound to obtain a blend that's $5 a pound? Okay. So this is a mixture problem like the nut problem we worked, or like the coffee problem that we did earlier also. So we're going to do an amount. We're going to do the price per pound, so dollars per pound. And then in the last column, we'll multiply those two together. So amount times dollar per pound. Okay, so I'm going to come and call this the cheap stuff, the expensive stuff, and the middle of the road stuff. So that's going to help me get those dollars per pounds in there. So the cheap stuff was $4 a pound. The expensive stuff is $8 a pound. And the middle is the $5 a pound. Okay, what else do we know? Well, we also know that of the cheap stuff, we already have 20 pounds. And that's all the numbers that they gave me. They only gave me the 4 numbers. There they all are. What they're asking is how much of the expensive stuff do I have to mix in order to raise the price a little bit, but lower the price on the expensive stuff. What's that going to give me down here is my total. So don't forget that this bottom line is really the total, right? So if I had 20
plus
pounds,
x?
yep, beautiful. And does it matter whether I write it as 20 plus x or x plus 20? Beautiful. Okay, I'm going to stop there because you guys can finish it. We've got the chart filled in as much as we can. You finish it from there. That way I know you're writing the equation without my help. So Okay, and then everything else that's on your review to date worksheet for Saturday, we've already talked about. So you should be good to go. Any comments or questions?
I'm good.
Okay, so again, no class Monday. I won't be here. I've actually deleted the meeting time, so you shouldn't even be able to log in. No class meeting Monday. But I'll see you on Tuesday. The code is still the same. You'll use that same meeting ID until we get through the end of May. So I think it's actually through next week. At that point, I'll have to go create another one. So they only let me do so many of them. Hey, everybody, have a great weekend. Enjoy your 4 days. Try to get outside and get some fresh air. I'm not going to tell you to go eat out yet because I don't even know if that's capable. So, comments? Anybody? Okay, have a great one.
Good.
Enjoy it.
Oh, I'm good.
Thank you.
Bye-bye.